Okay, in section 8.3 we're going to be discussing how do we add and subtract rational expressions. So we talked about last time how to multiply and divide rational expressions. So what we're going to do today is, again, deal with the other two operations, which is adding and subtracting. So to start out with, let's review what we know about adding fractions in general, because rational functions are functions that look like fractions, as we know, polynomial over polynomial. So if I had to do like, say, 1/2 plus 5 halves, okay, we know that from what we learned in elementary school that if we have a common denominator, we can go ahead and keep the denominator, we can add the numerators together, and we'd get 6 halves, and of course we would reduce after that, and we would get 3 altogether. Okay? Now, if we did not have a common denominator, so we wanted to add that to 5/3, add those two fractions together, then I would need to get the least common multiple of 3 and 2, which of course in this case would be 6, and change those both to a 6 denominator, which means that we'd have to multiply this one by 3 times 3, which is okay because this 3 over 3 is really just 1, and we could change 1/2 to an equivalent fraction of 3/6. Okay, same here, we'd multiply by 2 to make the bottom a 6, 2 on top would make it a 10, which again 10/6 would be the equivalent fraction to 5/3 with a 6 as the denominator. Okay? So with that said, now we can go ahead and add, and we can get 6 on top, 13, or 6 on bottom, 13 on top, and we can get our final answer of 13/6. So the question then becomes, how do we do that? How do we deal with that in an algebra situation? Okay? Well, in some cases, it's going to be exactly the same. If we have a couple of monomials, like say 5 over x squared plus 4 over x squared, we can see that we have a common denominator already. So we would simply leave it as x squared on the bottom, and we'd add the tops, and we get 9 over x squared, and we'd be done. Okay. If we had a couple monomials like x and x squared, say 3 and 2, if you will, and say we're going to subtract this time, and we don't have a common denominator, then we need to get one. So the question is, what would be the LCM of these two? Well, if I have x and I have x squared, both of those could go into x squared. Okay, x squared, of course, would only go in there once, which means we'd leave it as is. But then what do I multiply x by to get x squared? Well, I could multiply by x times x. So if I can find a strategic number to multiply this one by to get this one, then that one can be the common denominator. So in turn, though, I'd have 3x on top when I find the common denominator. And of course, I'd keep it, and I'd deal with the numerators, tops, which would be 3x minus 2. And in that case, I'd be done. Okay. Let's take a look at one of your problems, number 5 on your practice is x over x squared minus 4, and then 2 over x squared minus 4. Notice this time instead of having a monomial denominator, we have a binomial denominator. However, you should notice that they have exactly the same denominator. So therefore that part is done. And on top I can go x minus 2. Now, one thing that we have to be careful with here when our directions here are to simplify is this may or may not be done when we do that addition or subtraction. Okay, because if we look at this, we should recognize right away that we have a difference of perfect squares here. And if it does, then just like we did in section 8.1, we're going to want to simplify if possible. So if we factor the bottom into its difference of perfect squares factors, we can see that those two would in fact cancel out. And so therefore the final answer would be 1 on top, because there's nothing left besides 1, and x plus 2 on the bottom. Okay. So careful when we add and subtract that there may, when we get done, be some reducing to do, which is not really any dissimilar to what we did in the first place when we did this problem. We ended up with 6 over 2. We certainly wouldn't leave it like that. We would, divide it or reduce it by its common factors and get a final answer of, in this case, 3. Okay? So again, this process of doing what we just did here is exactly the same as what we did above. Okay, let's look at another example of a monomial denominator. This is number 6 in your practice. You have 7 over 20x plus 3 over 5x squared. Okay. Thinking about what would be the LCM of these two. Well, we already know how to deal with the x and the x squared. We had that earlier. But if we have a 20 and a 5, just pretend if those weren't there. The LCM would be 20, of course. So if we just did 20x squared, both of those would go into 20x squared. So strategically, we multiplied 20x by x to get 20x squared, so therefore we'd have to multiply 7 times x also. 5x squared times 4 would get us to 20x squared, so 3 times 4 would get us 12. And once again, keep our denominator and add our numerators, and we're done. And the final one, similarly, is your number 14 on your practice. You got 4x squared minus this time 9x, which is just 9x. We need to get a common denominator though, again, because we don't have one with x and x squared. It's x squared, of course. This one does not need to change because it was already x squared. This one got multiplied by x, so therefore we have 9x on top. And then, of course, we have x squared on the bottom. Keep the denominator the same. And if I do 4 minus 9x, we're good to go. And that would be the final answer. Okay. So, in terms of adding and subtracting rational functions, rational expressions, okay, we're only going to handle the fairly simplest types. Of course, we could make these a lot more complicated with denominators that are more difficult to find the common denominators for. Okay, however, in this class, we're just going to stick with the basics, if you will, and we'll end it with that.